Hi there, today I'll be explaining you the details of polyvinyl chloride, or known as PVC. Now, let's us look at how PVC is made industrially and its uses. PVC is generally made from the raw materials of ethylene and chlorine. Ethylene may come from thermal cracking process of heavy distillates such as naphtha or decane from the fractional distillation. Ethylene may also be obtained from natural gas or light distillate from the distillation column. Chlorine, on the other hand, is extracted from the seawater during the process of electrolysis. First, react together chlorine and ethylene, which gives ethylene dichloride or EDC, in this process called direct chlorination. The second process is the oxychlorination. Unreacted ethylene from the first process is mixed with air enriched with oxygen and hydrogen chloride, HCl. HCl is obtained from the cracking process of EDC, which is the byproduct of the descent back to the oxychlorination unit. Back to cracking, the chemical reaction to convert EDC to vinyl chloride, VC, normally takes place in the furnace at a higher temperature. The VC is then polymerized to form polyvinyl chloride, PVC, where more and more VC molecules are linked together to form carbon long chain. The polymer chain is finally separated and drying until form a fine powder or pellets for further processing. The main and most important process in PVC making is polymerization. This process starts up with breaking down of organic peroxide by UV light, creating two free radicals. This causing one chloroethene monomer initiates its reaction by combining with one free radical. The process of forming new monomers chains continue and known as propagation. The combinations of monomers will eventually stop when the two free radicals attached with monomers hit each other in this process called termination. Therefore, PVC has now been formed. Next, the uses of PVC. Considering their properties, PVC has used in a variety of application. This includes building and construction, such as manufacturing of siding and window and wiring and cables. Due to their durability and lightweight, PVC also helps in packagings such as blister and clamshell packaging. PVC also plays a critical safety role in healthcare, for instance with the advent of blood collection bag from PVC are made due to their flexibility and unbreakable properties. Last but not least, PVC's affordability, durability and water resistance make it ideal on household products such as raincoats and shower curtains. Now, let's us understand the current condition of PVC. Are they simply being thrown out in the garbage or will be reused? The existing of the PVC as the waste do not necessarily end up in the landfills. This is because the additives in PVC plastics containing high chlorine content create further landfills problems by their chemical leaching into soil and water. These chemicals pollute groundwater and air quality, impose harmful effects on human and the environment. Considering these major drawbacks, PVC will be further reused to manufacture other products. Now let's take a closer look at the end life of PVC. So, the question may be raised here, can PVC be recycled and reused? How long do recycled PVC products last? Certainly, PVC can be both recycled and reused. European countries especially are leading the way for more sustainable use of PVC with programs such as Recovinyl and Vinyl Plus, aiming to divert as much as possible PVC waste from landfills. There are mainly two methods of recycling PVC. One is mechanical recycling, where this process involves mechanical treating such as grinding to break it into smaller pieces. After that, these pieces will be melted, remolded and eventually form new products. Another method is feedstock recycling, where this includes chemical process such as hydrolysis to convert the waste into its chemical components and thus new PVC. According to their durability, PVC can last for 25 up to 40 years, which saving tons of manufacturing energy use. Last but not least, let's look at some developments in producing more eco-friendly PVC. The inventory of PVC has caused adverse effects on the environment. Therefore, new research and development have been widened with respect to the substitution of PVC. The non-chlorinated vinyls such as ethylene vinyl acetate, EVA, polyethylene vinyl acetate, PEVA, polyvinyl acetate, PVA, and polyvinyl butyryl, PVB, are now applied commercially. Undeniable, some of them still have plenty of toxic challenges and untested chemicals, but they have proven to be more eco-friendly compared to PVC.